Hello, NuPIC. This is the NuPIC office hour for February 9th. We had some technical difficulties with the other Hangout, so I just left it open. So don't join that one. It doesn't work. It's not even running. So this is attempt 2, and it seems to be working and broadcasting now. So I am Matt Taylor, and in front of you, we've got Chetan Subutai, Jeff, and Scott. And we're going to be answering your questions from the NuPIC community. So let me share my screen here. Yeah, I love that. Okay, so this is the wiki page that I sent out on the mailing list for people to add their questions to. Rick suggested we have the IRC window open, so hopefully, Rick, if you're seeing this, type something so we can just make sure this is all working now. But in the meantime, we have some interesting questions here. So let's just start from the top. Some of them at the bottom are pretty detailed, so we'll start from the top.
Do we know there's anyone on right now? Can we tell that?
Let's see. Yeah, 0 viewers at the moment, but it is being broadcast on YouTube. That's probably just because we had to switch from one event to the other.
So it's not worth waiting.
It's being recorded, so people.
Yeah, I don't think it's worth waiting because we usually do the Q&A questions at the end of the wiki questions anyway. So that'll give people a chance to join and see what's going on. So let's start with this first question from Michael. When a column sees new input for the first time, all the cells in the column become active. Once that input becomes part of a predicted pattern, only one of the cells will be in a predicted or active state. How does a column choose which cell is going to represent the expected input? Is it based on connections to cells in different columns? And
all right, let's do it.
That's gonna happen every time. So we have a whiteboard. If you want to use it, you can.
I think there's something.
This one's pretty straightforward, I think. So this is referring to the temporal memory algorithm. So when you get an unexpected input, the columns burst, and then you have to pick some cell that's going to learn transitions to any previously active cells. And so the way we do it in temporal memory is we first try to see if there's a weak match. So if there happen to be any active cells previously, but it wasn't enough to make the cell predicted, but it's still above some small threshold, then we say it's a weak match. And if it matches there, then we learn on those cells. And then if there's no match, then we just randomly pick a cell. And so you want to be careful that you don't pick, you want to pick something that's random in the case where nothing matches. Otherwise, you actually won't end up getting a higher order context. So it's important that it be somewhat random.
In between a weak match and completely random, we look for the least recently used cell.
Right, to sort of fill it up.
Yeah, to encourage good distribution. And if there's, and then we tie break randomly between equally least.
I don't think any of those are essential components. I mean, make sure that it's not always the same cell is essential, but there's lots of ways you can go about it. That's one we did, and seems to work all right.
Okay, so this is a part of the temporal memory algorithm that's not part of the white paper, the older white paper, right?
No, the white paper has this. I think Chetan's temporal memory implementation is the cleanest place to look for this.
But this hasn't really changed, I don't think.
All right.
Not really.
So Michael, if you're watching, if you haven't looked at the white paper, this would have been explained there, right?
Yeah, it's not. It is in the white paper, but you have to kind of dig in into the pseudocode to get it.
This is a cleaner getting an answer just this way. It's easier.
Yeah. Okay. I'm still sort of debugging live what's going on with Hangout. So.
You have 3 viewers.
It looks like we have 3 viewers, but Rick still says he can't see us. I'm just putting something in here to see if anybody is watching. In the meantime, we'll just move on to the next question. Because it looks like everything's working now. Okay, question number 2. This is from Michael Roy Ames. He's just recently signed the contributor's license, so maybe he has some intent to help us work on this. How do we allow new learning to happen whilst guaranteeing the retention of valuable old learning in the NuPIC network? Are there examples of NuPIC networks forgetting older learning has this been problematic for anyone? So maybe we could go into the background, but
I think we can just talk about it in general, right?
Yeah.
The question is pretty well stated. Well, first of all, it hasn't been problematic for us. We have a method for doing this. And in some sense, well, do you want to take this one again? Because you were just talking about
no,
it.
you can.
No, I thought you had an explanation for it.
Okay. So in the temporal memory, there are a few things. So we don't have any mechanism to force a set of permanences to just stay, permanently. And so there might be something like that in the brain. So if you touch a hot stove, for example, you're going to remember that no matter what happens in between. You're going to remember that the rest of your life. So we don't have any mechanism like that. But in general, in the temporal memory, the learning is contextual. So if you get a certain particular context again, but something different happens in the future, it'll slowly override that one. But if you don't see a particular context, those memories will stay on for a long period of time. So,
yeah. Well, another way to put it,
there's a pretty large capacity in the temporal memory to.
Maybe another way to put this is a couple of things. Is the whole idea of the permanence is that you can increase the longevity of a synapse beyond the point where it's becoming effective, right? So the idea that you can keep increasing the permanence up to 1 is a way of saying this connection needs to be remembered longer than ones that haven't gotten to 1. Sort of that's the basic idea behind it. And it doesn't become more effective; it just becomes more long-lived. So it takes longer to forget. I think what Subutai was saying is the capacity of the system is quite large, so you can learn quite a lot of stuff and not forget things. But we did want to impose. Is this still working? Yes. Sorry. We did want to impose. We had a fundamental decision to make about whether the network has a fixed amount of resources or a dynamic amount of resources. And the closest analogy in biological systems is a fixed amount of resources. Although we do grow new neurons, basically we assume that you've got a certain amount of neural tissue, a certain number of columns for any particular short-term learning task. And so in theory, as you learn more, eventually you'll start reusing segments that had been allocated for something else. And the algorithm we use, in some sense, use the segments that are closest to ones you already had. So it sort of has a very gradual failure or gradual degradation as you fill up. And of course, things that are more permanent will last longer. But as Subutai mentioned, it's biologically possible, it seems likely actually, that there are other ways that make the learning, you can have some learning even more permanent based on certain factors, but we didn't model that. But in general, it'll remember things for a long period of time. Things have been exposed more, it'll remember longer.
Mm-hmm.
Okay. Whoops. Okay, sorry, I'm working out technical issues while they're explaining things. Okay, let's move on to the next question from Michael Klochko. I've heard that the proper temporal pooling implementation, that's a term I think he gets from me, that's what I always refer to it as, the proper temporal pooling, is a missing critical feature, holding back people from doing great things with NuPIC. I think he's talking about hierarchies, networks and stuff. Is that true? If yes, is this task being planned or worked on? I looked at the roadmap, I didn't see anything about that. That's true. Is there a different roadmap with the conceptual development plan? I guess we should give her sort of an overall state of where that is in the phase of development.
I don't remember what the roadmap shows.
Well, he's talking about our development roadmap. We're not even talking about it yet.
Yeah, so the development roadmap is focused on the next few weeks and next couple of months for NuPIC per se. Then there's the NuPIC research repository, which contains all of our research code and all of the tasks that we're working on from a research standpoint. So the temporal pooling work would be tracked there, and you can look at the GitHub issues there and the wiki page there. And we don't promise to keep that updated regularly, but we try to. So you can try to get a feel of what we're working on over there.
Well, let's just answer the question specifically here.
Yeah.
So in terms of doing great things with NuPIC, we can do a lot of good things with NuPIC today. But if you want to do something that requires any sort of a complex hierarchy like computer vision or some other task, then the temporal pooling mechanism will be required for that.
So I don't think that's depends on your perspective. You can think of it as what's critical or not. We think it's actually more critical, or at least we're working along the lines of adding the whole integration of motors, so sensory motor inference and sensory motor planning, which can all happen in one layer of cells or one region of the cortex. And some of that requires temporal pooling, but the point is we're not at the moment focusing on building a hierarchy of single layers like you might want to do for certain types of vision systems. We're focusing on figuring out the rest of the whole interaction of layers in the region and how to integrate the other functions of motor planning and motor inference that we haven't done in the past. So it's a choice which one you want to do. I think that's more critical, but time will tell. But that seems to be to us a larger piece that we'd like to focus on as opposed to going up in the hierarchy. I think we're pretty close to temporal pooling, understanding how it works.
I think we've worked through a lot of the sensory motor inference and temporal pooling, corner cases and so on. Chaitin has written up a nice wiki page exploring kind of the limits of sensory motor inference and temporal pooling, like how many different things you can pool over and so on. And there's a long kind of write-up of that, and so that's kind of our current state of.
Yeah, I want to show that real quick. Okay, so this is the NuPIC research wiki. There's quite a few pages in here. This last one, I think you shared this with the mailing list.
Yeah.
But yeah, I think the short answer to the question is sensory motor integration first, then we'll start.
We worked on temporal pooling. I don't know if it's just not, we're not building hierarchies, and I don't know if this code is.
It's in NuPIC.research, it's not in NuPIC per se.
Yeah, NuPIC research.
Is it in a condition where someone who wanted to work with it could use it, or no?
It's not supported. I think the comments in there might be confusing because it's very active code. And
Okay.
I think there's an issue. There's a pull request there to improve some of the comments on there even today. So it's sort of very active.
I wouldn't recommend anyone trying to use NuPIC research.
Yeah.
Unless they're maybe a contributor and are working directly with the things that are being done there.
Well, I just wanted to say it's not like a big mystery to us. We have a very logical, complete, or seemingly complete theory about how temporal pooling works. It's not that complicated.
Well, as a follow-up question, in the old version of NuPIC, there were hierarchies involved there. So
we had in the CLA white paper, there was an explanation of temporal pooling. We talked about this before. That we've abandoned a while ago. And we have a new implementation, which we've been using conceptually for the last year or so, and detailed more recently.
But what do you mean using conceptually?
Well, I mean, like we mentally made this transition a while ago to doing a new way, which is using the proximal synapses, proximal dendrites, as opposed to the way we described in the white paper, which is sort of a chain of dendritic activations. And that's what Chaitin tested, and that's what this capacity test you just showed implements.
Okay. So is it fair to say that the work being done in sensory motor inference is sort of the groundwork is necessary to put in place the proper temporal?
No, actually the other way around. I think temporal pooling is actually necessary to do the other way. But my point is, it's in terms of what we've submitted, the code, and what's in the NuPIC itself. What are we working on right now? We're not trying to build hierarchies. We're just focusing on I actually think the temporal pooling part is easier, and it's a simpler thing, and we sort of conceptually got that to a point, put it aside at the moment. Now it's required to do. It's going to be required to figure out how all the layers in the region work together.
Are we going to be able to? Now I'm hijacking the topic, but are we going to be able to do anything with the sensory motor work that's going on in NuPIC research without temporal pooling? Once it's that, would you say it's production's ready capacity?
Sensory motor.
Yeah.
Sensory motor.
Will people be able to take advantage of the sensory motor work that's done once it's done and merged into?
Yeah. So it depends what you mean by take advantage. I think if you want to understand how sensory motor inference is done in the brain, you can look at the code and run it and get some insights from that. But I don't think it's production ready in the sense that using it to solve some commercially valuable problem. I think we're still pretty far from that.
Okay.
But in terms of understanding how it works, I think you can use the code.
That's a good way of putting it. You can understand how it works today, although we just haven't made the code robust.
But there's no dependency from going from temporal pooling to sensory motor stuff or vice versa. Those are completely separate conceptual topics, right? You could have one without the other. And
You can do temporal pooling without doing sensory motor inference. You can do it to create stable representations of sequences, just high order sequences.
Okay.
So you could, someone could try doing that with the code.
Okay. So yeah, thanks for entertaining my questions. Speaking of questions, if we have 8 viewers, if you guys have a question, use the Q&A interface. It looks like a Q and an A. And you can type in your questions there. I think if you type comments, it might actually show up as questions as well. So go ahead and start typing questions. We're going to continue going through wiki questions right now, but we'll get to the Q&A questions. Okay. Next question. Okay, I think all of these next several questions are from Eric Locken. He's the guy who's been working on the continuous HTM idea. I've been kicking around, connecting with him a little bit more closely. So his first question is, how do you handle SDR chasing in NuPIC? By that I mean when a column learns the input too fast for other columns to ever get in between, so it dominates everything and the SDRs never change. In continuous HTM, this is a problem, and I know of some solutions. So just an offside, we don't totally know how continuous HTM works. We haven't been researching that.
I don't think we can talk about that, but we can talk about, if we understand this question, we can talk about the issue in terms of
so it's sort of how do you get to a stable SDR?
Well, it sounds
not stability, but you don't want the SDRs to be changing from under you all the time.
Yeah.
So he says, I assume the fact that NuPIC uses discrete input SDRs helps a lot, but is there something else in particular that might mitigate this? Apparently this is a problem he's having in his continuous HTM scenario. I don't know if we have this problem in NuPIC.
Well, we did. We don't now. If I understand the question correctly, maybe I'll start speaking about it, and then somebody can think if I got the question wrong. If you're chasing, it sounds like stability of the representations, like a problem where the representations are changing, and you can't really have that happen quickly. You can have it slowly if the world changes and you want the representations to change. But we did have a couple of corner cases where this occurred in the past. One was the case where you had a very, very limited amount of input into the system, so that the system actually didn't see a lot of different patterns. It only saw a few patterns. And the way the system tries to work, that all the cells are trying to, all the columns in the cells are trying, it's an aggressive learning strategy, and they try to represent something. They want to divvy up the input space into a nice clean divisions. And if you don't have enough input, if you only have like 3 patterns coming in, they can fight over it. So that's a non-biological problem. That doesn't occur in biology. But we did implement some special code that says, look, we have the way we start training a new spatial pooler is if it doesn't see enough, if it hasn't seen enough unique things coming in, then it has a sort of a corner case preventer in that.
Yeah, I think if it's in the code now, but what we did was if there was an absolutely perfect match, then it sort of overrode the boosting.
Yeah, so we had this idea of boosting, which is the aggressive behavior to sort of spread out the love among all these different SDRs, or all the different columns. So that was a corner case that wouldn't apply to anything like real, like vision or something like that. I don't know if there's another interpretation of that.
I mean, you want to make sure your learning rate is not really fast, otherwise you could get oscillations in your spatial pooling, I guess.
Well, I think there's a trade-off between learning rate and what part of your historical data stream you're focused on. If you have a high learning rate, the system will basically adapt quickly to the things that happened very recently, and will more quickly forget things that happened in the past. If you have a slow learning rate, it basically will ignore or it'll take a much longer time for new patterns to basically play a role. So if I have a slow learning rate and I see some noise, I'm just going to learn a little bit. I'll have to see it many times before I start saying it's real. And therefore, I'm more likely to retain old stuff. So that's not a problem. It's just a matter of where you're living in the world. Do you want want to react to things that happened quickly recently, or do you want to react to things that happened a long time ago? There's no a priori way of knowing what the right answer to that is.
And that's configurable in
It is
current
configurable,
NuPIC and as a model parameter. It's
Yeah.
one of the model parameters.
Yeah.
I don't remember what it's called. Okay, another question from Eric is, so he's currently storing Q values for SARS. I'm sorry, I have no idea what that means. In cells, so that each configuration of cells produces a unique Q value. This works quite well. Is it the way the brain does it? Is there any evidence of this?
I think I can take this one. Super, I had mentioned before we started this. We have the CLA classifier, which basically takes for each of the cells stores essentially a prediction of what would happen next when that cell's active, and then the cells all vote together, and then we use that to come up with a prediction for however many steps in the future. So I think what's happening here is that the Q values stored are essentially a predicted max reward for each possible action. And it's storing a set of those for each combination of active cells. I think that's what he's describing here.
Okay.
And if that's the case, that could be a useful way to do a reward behavior type problem. I think to ask if this is what's happening in the brain is, I think you instead have to come up with a proposal for how it is happening in the brain that achieves this functional result, and then we could compare that to the literature. But to just ask, is this what's happening in the brain? I don't think we have any idea of any way of saying yes or no at this point. We don't really know detailed enough what's happening. Yeah. And this is something we're actively looking at, so hopefully we can contribute more at some point.
One thing I would add is SAR cell specifically is state action, reinforcement, state action. So it's all of those together into one cell representation, not just the state of the action.
Okay.
I mean, in general, it's difficult to take concepts that were derived without any consciousness of the neuroscience and say, hey, this is how it might work on the brain. It generally doesn't work that well. But our approach is really, as Scott was saying, really understand how the neurons will actually implement this stuff. And then in something like these concepts like Q values could influence your thinking about that, but it's unlikely you're going to say, oh yeah, here's a Q value stored in this, I don't know. I don't even know what, I don't even know.
If we figured out the biology, we might be able to show that it's
doing something equivalent to
yes.
I think we'll end up typically finding, say, well, it solves the same problem slightly differently than I thought about it. But yeah.
Okay. Eric has some more questions. It's going to get interesting here. Eric recently spoke to Jeff Hinton in person a few weeks ago, and he said he doesn't believe in HTM since it's still based on hidden Markov models or something like that. I can't remember exactly. I think he means that only one cell per column is active at a time in the white paper, so you need a lot of cells to get enough possibilities. So he's asking, is he justified in this? To me, it seems like it isn't such a big deal that the amount of memory needed goes up linearly, but he seems to think otherwise. The other option, which I assume he was thinking of, is to use all possible combinations of bits to represent the cells. This is how continuous HTM does it. This is Eric's project. But I do not have theoretical justification yet, only experimental. When I mentioned this, he said, then it's not HTM anymore, which I find very strange. How strict is the HTM?
So I don't think we know what Jeff Hinton is thinking about our work and what he meant. I think the specific comment there that there's only one cell per column active at a time, that's a misunderstanding. I mean, even though there is only one cell active at a time, some people very naively think, oh, well, if I have 30 cells in a column, I can remember 30 elements or 30 different representations, which is not true at all. As we made clear many times, since you are showing this as a set of column representations and a set of cells, that the number of possible combinations of one cell per column out of n number of columns is astronomically large. So we don't have actually any representational issue at all with high order representations in columns. There's none. It's just astronomically large number. So and memory doesn't go up linear at all. As we said earlier, we work with a fixed amount of memory generally, or a limit to it, and it's quite large capacity in this regard. And so this issue, if that's what Jeff Hinton's thinking, he misunderstood how those cells and columns work.
And just as, I mean, it's not, the HTM algorithms aren't derived from hidden Markov models or anything like that. They're completely different branch.
So I suspect Jeff Hinton doesn't really know what our work is about. I can't be certain.
I wonder if he's still thinking about the really old versions that had belief propagation and did have more direct ties to hidden Markov models. Maybe he's sort of still thinking of that.
Yeah, it might be. Yeah.
He amplifies. Another thing Hinton complained about was the use of columns to represent contextual hidden information, as opposed to just representing some sort of features of the input. To me, this doesn't make any sense. Perhaps I just misunderstood, since the HTM information isn't really lost, since it's always available at the lower layers. It seems to me that Hinton had the idea that feed-forward architectures must have extremely descriptive features even at the highest layer, so information isn't lost at higher layers. This seems in line with his critique of max pooling. In HTM, when predicting, you can use all the layers which contain fine grained to very coarse information, so information is never really lost.
The first sentence here sort of implies, I understand this first sentence here, it implies that he's complaining that we actually have hidden information, which also is this contextual thing. So, but that's sort of a basic requirement of sequence memory. So I don't know if I'm misreading that statement or not. I mean, you have to, like we just read this Larkham paper recently, and he talks about this, the need for this. This is something you need in sequence memory. So am I misreading that sentence somehow? I mean, you don't want just feed-forward information. You must have contextual information. I don't know if it's hidden.
And when we say contextual, we mean temporal context.
Yeah, or anything which is anything which is not just representing the current feed-forward input.
Right. I think hidden is the wrong word. It's contextual. You can't understand it without the context. Doesn't mean it's hidden.
Right.
It's just,
Yeah, I don't know. Well, it depends. Who knows what he means by hidden?
Yeah.
I think that word means something in neural network architectures more than it does for us. So, but I don't know that. I have trouble. I don't know what Hinton's thinking, but it seems unlikely. That feature is an absolute necessity. So if he doesn't like it, I don't know what he has proposed instead. It's like that's the beauty of the temporal memory. It has this beautiful way of doing that. It's very hard to come up with a nice way to do it.
Okay. It seems like we've run out of wiki questions. And yeah, I think that was it. Let me refresh the page real quick.
Right.
Yeah.
Right.
So that's all the questions. And nobody joined in on Q&A. Hopefully it works. I saw a couple of people chatting, but no one asking questions. So I think that is it.
All right.
So that was a NuPIC office half hour for February 9th. If you guys have any more questions, we might put off office hours for a while until we accumulate some, and then sort of have them ad hoc once we have more to talk about, because I hate to take everybody's time for a block of an hour and we only use half an hour. So if you have any more questions, I'll start keeping a place for them on the wiki and send a message to the mailing list. So thanks everybody for joining in and watching, and we'll see you on the mailing lists. Take care.
Bye.